Today we are going to talk about JMP tools for engineering students and professors. We're going to talk about how to summarize and graph data in JMP. We'll talk about how to compute statistical intervals and hypothesis tests. We'll see how to build different types of models in JMP, including least squares regression models and nonlinear models. We'll see different tools for designing and analyzing experiments in JMP. And we'll take a sneak peek at some of the quality tools that are available. As we're working through this webinar, I'd like to point out that everything that I'm going to be talking about, we have information either through our online help or through the help within JMP under the help menu in the searchable books or the index. And I'd also like to point out our learning library. And the link for this is jump.com/learn, which has short one-page guides that walk through how to do basic tasks within JMP. So if I go too fast at any one point, keep in mind that there are resources, and this jump.com/teach gives one-stop shopping for all of these different resources. So let's go ahead and get started with talking about how to summarize and graph data in JMP. And I'm going to be using a Mac for this webinar, but everything that I'm going to be doing is also available directly in Windows. And I'm also using this little journal just to help keep track of where I'm at and provide quick links to data sets. All of the data sets I'm going to be using are available under the help menu in the sample data directory. And this sample data directory has hundreds of data sets grouped by type of analysis and also by category. If you click on one of the gray icons, this will display the data sets available along with potential uses for the data sets. And if you're looking for a quick alphabetical list, there's a button for that. So I'm going to open up one of these sample data sets. This will be a generic data set, US demographics, and we'll see some quick methods for summarizing data in JMP and also for graphing data. And I picked this data set because there are a lot of variables. This is some demographic information on all 50 states. We have 16 columns and then 50 rows. If you're relatively new to JMP, this icon next to the column names under the columns panel is one of the most important things in JMP. This icon indicates the modeling type of the data. And I'll right-click right on top of one of these icons so we can see all three modeling types. The blue triangle indicates that we have continuous data, so calculating a mean makes sense, having a decimal makes sense. Ordinal, if you see green bars indicate that we have ordered categories. And then if you see red bars, this indicates that we have categorical data, which is simply labels. So let me change this back to continuous. The reason this is important is that JMP will make some decisions for us when we choose our menu items in terms of the analysis that makes sense based on the data that we've selected. So the methods for summarizing and graphing data that we're going to take a quick peek at today, under the columns menu, the columns viewer for summarizing a large number of variables at one time. And this is a nice first step at analyzing data to get a sneak peek at the range of values and the way your data is coded. We'll see analyze distribution for quick graph and summary statistics. Tabulate, which gives you a nice little palette for dragging and dropping variables to create numeric summaries. And then graph builder is also a drag and drop palette for creating graphs. So let's get started. The columns viewer option is available under columns. And this is a new feature in JMP 11. And it opens up a dialog window that simply asks, which variables do you want to look at? I'm going to select all variables, and this is just a click and drag in one motion. And I'm going to ask to show quartiles as well. So I'm going to click show quartiles and then show summary. And what this shows is for every single variable, the number of observations. It shows the number of missing if we're missing any values. So notice under physical activity, we can see that we're missing one value. If data are categorical, we can see the number of categories. So we have 50 states. And we can see the number of regions. So in this case, we can see that we have 4 regions. This will also tell us how our data are coded. So notice that household income is showing a $sign. So this data has a numeric currency format. And notice at the bottom where we have latitude and longitude, these have a geographic format. Looking at the mins, the max, the mean, and the median gives us an idea about the shape and the centering and the spread of our data, along with the standard deviation. If the mean and the median are pretty close together, this indicates that our data are roughly symmetric. When I'm first looking at data, I'll look at the mins and the maxes to make sure the range of values makes sense. From this platform, if there are variables that I'd like to investigate further, I can select the variables here, and notice that it's also selecting them in the panel and back in the data table, and now I can launch the distribution platform. In the distribution platform, I'll go ahead and close this. The distribution platform is also the first option under the Analyze menu. Those three variables are still highlighted, and I'll select Y columns. And by default, JMP gives us some basic output. And I've changed a preference. The preferences in JMP are under JMP or File if you're on Windows. I've changed the preferences so that my output is horizontal. And you can change this on a one-at-a-time basis by clicking on the red triangle and selecting Stack. By default, we see a histogram and summary statistics for household income, and a bar chart and a frequency distribution for region. These are all linked together, so as I click on a bar in one graph, notice that it highlights the corresponding observation in every other graph and also back in the data table. Additional options are under the red triangle, and if we want to add additional statistics, we can select the options here under Customize Summary Statistics or Custom Quantiles, or there's a red triangle next to Summary Statistics where we can add additional statistics of interest. And if you're always looking for a particular statistic, again, you can set this as a preference under JMP Preferences or File Preferences. So this is dealing with summary data if you have a distribution platform and you're interested in looking at data one variable at a time. What if you're interested in looking at a dynamic way of summarizing your data? Well, this is Tabulate under the Analyze menu. So Tabulate gives you a nice little palette, and this palette allows you to drag and drop variables that you might be interested in. So for example, I might be interested in summarizing household income and IQ. I'll click and drag from the columns list, and if I move this over a zone, notice there's a blue box that draws over the zone. I'll let go of these two variables in the drop zone for columns since these are the variables that I'd like to analyze. And by default, we automatically get the sum. We can replace these by other statistics that might be more informative, like the mean and the standard deviation or any one of these, by clicking and dragging and selecting these variables and dropping them right on top of the word sum. This will replace sum with these two new statistics. There's a second drop zone, which is now a tiny little box, and I'll click and drag another variable and drop this into that box to break down the data by the values within that column. Now, if I don't want to see as many decimal places, this look is customizable. I can change the format, and I'll simply use the same decimal format for everything and click OK. If I'd like to add additional statistics or additional variables, I can simply drag and drop, and then these are automatically added. So this is Tabulate. A graphical version of this is our Graph Builder. So far we've been under the Columns menu for Columns Viewer, Analyze for Distribution, and Tabulate. The Graph menu has purely graphical options, and the most interactive of these is the Graph Builder. Again, the Graph Builder has a palette where we can drop variables. So if we're interested in looking at household income versus another variable, I'll pick let's say I'll pick 8th grade math scores. By default, we get a scatter plot and a smooth spline, and the icons across the top are graph types that might make sense for the type of data that we've selected. So from this same platform, we can do a fit least squares regression, we can ask for a contour or fit a line, ask for bar charts, and these options will update based on the type of variables we've selected. So notice that some of these are grayed out. Some of these don't make sense for the type of data that we've selected. For any graph element we've added to this, on the side, and I'll go ahead and maximize this window, notice that there are additional options. So far I'm displaying points, and I'm displaying a least squares regression line or line of fit. There are some additional options available. So I might want to explore if a quadratic or a cubic fit make more sense. I might want to display the equation or root mean square error. So these are all toggle switches to turn things on and off. There are additional drop zones, group X, group Y, wrap, and overlay, where I can drag and drop additional variables. So for example, I might want to break this down by region. And as I drag, and I'm not releasing yet, I get a preview of what the picture will look like if I let go. I'll let go and overlay, and this is color and size, and notice that as I move this around, the picture automatically updates. If I'm interested in box plots or bar charts, I'll again select household income, and this time I'll select region as an X. Now notice now I have some additional options available. Here's a histogram, box plot, bar chart, and I can drag additional variables onto this graph that might make sense. So now let's move on and talk about inferential statistics, and in particular statistical intervals and hypothesis tests. And we'll start by looking at one variable at a time, and then we'll talk about two variables at a time. And I'm going to open another data set that's part of the sample data directory, and this data is called cleansing. And what we're looking at, this is from a study from Myers from 1989, and the goal was to determine which of the three polymers, A, B, or C, best removes coal particles from a cleansing tank. pH is a covariate, and this was also recorded. So we've got one response variable, which is coal particles. We've got pH, which is a covariate, and we've got polymer. If we want to look at these variables one at a time, we use analyze distribution. And again, I'll select all three variables. By default, we see a 95% confidence interval for the mean. We see the mean and the standard deviation. And a couple of quick forms of help. If you see statistics anywhere within JMP and you're interested in more information on how the statistic is computed, take your mouse and hover around on top of that value. And if you're on a Mac, simply hold your mouse on top of that value. And what you'll see appear is a little box that pops up, and we call this hover help. And this will give you a definition of the statistic you're interested in. A second form of help is a question mark. If you click on your question mark on your toolbar, and if you're on a Windows machine, this toolbar may hide, simply click the Alt key to make it appear. Click on the question mark, and click on the statistics that you're interested in, and automatically JMP will launch the help files. So we see a 95% confidence interval for the mean. There are additional types of statistical intervals that we may be interested in. Under the red triangle, we see a list of available options, and these options will update based on the type of data we're looking at. Two additional types of intervals are prediction intervals and tolerance intervals. A tolerance interval computes a range of values likely to contain a certain proportion of our data with a certain degree of confidence. By default, we get a 95% tolerance interval that'll cover 90% of the data. And this will be a two-sided interval. And this is a parametric tolerance interval. So the way we interpret this is we're 95% certain that 90% of our observations will be contained within this interval. And this is a nice contrast or complement to a capability study. Now, a second type of interval is the prediction interval. And this is used if we want to predict an interval that's likely to contain the next value or the next range of values. So for example, if I want a 95% interval to contain the next 10 values, then we produce a prediction interval. So we're 95% certain that this interval will contain the next 10 observations. And then we also see the prediction interval for the mean and the standard deviation. Well, let's talk about hypothesis testing. A hypothesis test for mean is found under test mean. And this is where we can perform a z-test if we know the actual standard deviation, and we can also perform a non-parametric test. I'll plug in a value just outside the range of our confidence interval and click OK. Now let me minimize some of these other things we see. And when we do hypothesis tests in JMP, we get some nice summaries of what we've actually done. So we've hypothesized that the true mean value for coal particles is 340. We observed a sample mean of 301. Under the t-test section, we see the results from this test, our test statistic. And anywhere in JMP where you see prob greater than something, this is a p-value. In fact, this one, prob greater than the absolute value of t, is the p-value corresponding to the two-tailed test. And this t, whatever it has after prob greater than, is whatever the reference distribution is. In this case, it's the student's t-distribution. So we see that the p-value corresponding to the two-tailed test is 0.0342. This gives us evidence to reject the null hypothesis. The curve at the bottom is giving us a graphical representation of the test that we've just conducted. The curve is drawn centered at our hypothesized value. The red line is drawn at our observed sample mean, and the blue area in the tails represents our p-value. The less blue area there is, the lower the p-value. And these other two p-values, the sign of these p-values corresponds to the sign of the corresponding alternative hypothesis. So this bottom one, prob less than t, corresponds to the alternative hypothesis that the mean is less than 340. Now, if you're relatively new to statistics and struggle with interpretation of p-values, under the red triangle next to test mean is a p-value animator. And this p-value animator allows you to dynamically change the difference between our observed sample mean, which is here's 300, and our hypothesized value. And this allows you to see what happens to the t-ratio and the p-value if they're closer together or if they're further apart. It's also a nice ad hoc way to explore power. Instead of having 18 observations, what would this curve look like if we had 100? Or what would it look like if we only had 10? So again, this is the p-value animator, and it's under the red triangle next to test mean, and there's also a power animator. Now, a few additional options for continuous data that might be of interest. Continuous fit allows us to explore different distributional fits to our data. So for example, if we want to test the assumption that our data come from a normal distribution, this will overlay a normal curve on top of our data and give us fitted parameter estimates for this normal distribution, along with additional options. Other options available from here, if we have data that's in batch form rather than time order data, we can conduct a capability study. And we can also, under continuous fit, ask JMP to help us select the best distribution. Now for categorical data, and we don't have a really good example here, we have analogous tests. So for example, we can test probabilities, and we can also conduct confidence intervals. So this is looking at univariate data. Let's talk now about looking at bivariate data. When we're dealing with univariate data, we use distribution. When we want to look at one variable against a second variable, we use fit y by x. So we'll use this platform for simple linear regression, one-way ANOVA or a two-sample t-test, logistic regression, and a contingency table or chi-square test. And the assumption is that we've got our values, our observations in one column, and we've got our x variables in a second column. And if we're dealing with an ANOVA situation, the assumption is that our labels are stacked in one column as they are here. So let's look at the two different situations here. Our response of interest is coal particles. And we want to look at the relationship between coal particles and pH. The key on the side gives us an indication of the type of analysis JMP will conduct based on the modeling types of the variables that we've selected. So here we have a continuous variable against a continuous variable. Our y is continuous, which puts us here at the top. Our x is also continuous, and the intersection of these two is bivariate. Let's add polymer. So this will look at coal particles versus polymer, and this puts us here for one-way ANOVA. So we're going to conduct two different tests at the same time. And the tests are actually quite different because we're asking a different question. Notice that the labels are very different. In this case, we're looking at pH versus coal particles. And if I click on the red triangle, We see things like fit mean, fit line, which means fit a simple linear regression equation, fitted polynomial. So we see a lot of the word fit. Here we're assuming that we're fitting a model of some sort. Under one way, we see the word mean, means ANOVA, means and standard deviation, analysis of means. We're asking a completely different question here. We're asking, is there a difference between the means or the medians of these three groups? So let's explore these options. If I click on the red triangle for bivariate fit, fit line fits the least squares regression line. By default, we see the fitted regression equation, a high-level summary of the test or the fitted equation. We see the whole model test results under the analysis of variance table. And then we see under the parameter estimates table the coefficients for the slope and the intercept. All of these tables are live, active tables. So if you right-click on any one of the tables, there are additional options. So for example, if I go up under columns, notice that we can ask for upper and lower 95% confidence intervals for the coefficients. If we're in a design situation, we can ask for VIFs. And one option in JMP Pro that's available is bootstrapping. So in JMP Pro, there's dynamic one-click bootstrapping in almost every platform. Now, additional options for this fitted line are available under the red triangle next to that option. So for example, I might want to start by looking at the residuals, or I might want to look at confidence curves or some other value. One more thing under the red triangle here, and there's a lot here, is you might be interested in exploring the correlation between these two variables. You won't see that word here per se, but if you select density ellipse 0.95, this will fit an ellipse that gives you a graphical representation of the nature of the association between these two variables. And then if you click on the gray triangle next to correlation, you'll see the Pearson's correlation and a test for significance. If you're interested in doing pairwise correlations for more than two variables at a time, go to Analyze, Multivariate Methods, and then Multivariate. So this will do a series of pairwise correlations. So let's talk now about one-way ANOVA. So here I'm asking the question, is there a difference between these three groups? I'll click on the red triangle, and if I ask for quantiles, this will give me some basic summary statistics. So I'm looking at the minimum and the maximum and the quantiles. And these are all toggle switches. If I go down to the bottom where it says display options, there are a number of graphical options available. And if you're dealing with a large data set where there are a lot of observations per group, one of the things that I turn on is this option points jittered. And what this will do is that it'll jigger the points a little bit so that you can see unique observations. And again, I encourage you to explore the options that are available. From here, I can ask for means ANOVA. I can do pairwise comparisons between groups. There's a series of non-parametric tests that are available. I can test for unequal variances and do equivalence tests. And we've added robust tests to deal with outliers. So let me go ahead and select means ANOVA so we can see what that looks like. In JMP, when we represent a confidence interval, we use what we call means diamonds. The tips of the diamonds are the ends of 95% confidence intervals for the means, and the center of the diamond is the mean for that sample or that level. And these give us a way of graphically comparing the means for the different groups. From conducting ANOVA, we see the summary of fit, which is a high-level summary of our analysis. We also see an ANOVA table. In this case, we have a significant p-value. And then we see the means with confidence intervals for each of the groups. If we'd like to be able to compare particular pairings of these groups, on the red triangle we use compare means and then one of the four multiple comparison procedures. And just so we can see how this works, I'll select compare means each pair students t. What this will allow me to do is do all possible two-sample t-tests between a mean and every other mean. If I scroll down to the bottom, we'll see these tests have already been conducted using more traditional methods. So we see the connecting letters report, and we also see p-values for each possible test. And we've added a tool called comparison circles. What a comparison circle is a graphical way of exploring differences. I clicked on the top circle, and we see across the bottom that A is highlighted in red. This indicates that I've selected the mean corresponding to polymer A. Notice that the center circle is red, but it's thin. This corresponds to the mean for polymer B. So I've just done a two-sample t-test between A and B, and since they're the same color, this indicates that A is not different from B, or the mean of A is not significantly different from the mean of B. Notice that C turned gray and is in italics. This indicates the mean for A is significantly different than the mean for C. If I click on the center circle, this corresponds to the mean for polymer B, and notice that B is not significantly different from either of the other groups. Now, if you're dealing with a lot of pairwise comparisons, then the Tukey test is recommended, and this will control the overall experiment-wise error rate for the test. And to specify your own alpha level, if you're doing a Bonferroni test, then you can set other and enter your own alpha level here. So this is looking at data, two variables at a time. And keep in mind, we've skipped two of these options. If you're dealing with a categorical Y, there are two additional options available: logistic regression and crosstabs and chi-square. So let's move now into building models. There are a lot of different types of models in JMP, and we'll take a look at just a few of them here. We'll see how to fit a linear model. We'll take a sneak peek at our nonlinear modeling platform, and we'll take a look at survival and reliability for looking at time to event data, or data that are highly skewed. The fit model platform is highly flexible, and it's really a workhorse within JMP. And we'll use the same data set, and the option is Analyze Fit Model. By the way, I should mention I skipped over matched pairs. Matched pairs is used if you're doing a paired t-test where you have dependent observations in separate columns. By default, what JMP will do is compute a column of differences behind the scenes and perform a one-sample t-test on these differences. The key is that we've got dependent data. If we've got independent data, then we're going to use fit y by x. So let's go on to fit model. Now, fit model under personality shows us all of the possible things that we can do here. By default, if we have a continuous y variable, the platform will do standard least squares regression. But some of the other options are available. If we're dealing with very large data sets and we want to be able to have some help with model selection and reduction, we have stepwise regression, and this also includes all possible models and model averaging. If you have JMP Pro, this platform will do generalized regression. And generalized regression does many wonderful things. One thing it does is that it gives you different response distributions. And the other thing it'll do is it'll fit elastic nets, lasso, and ridge regression models for cases where you're dealing with highly collinear data. So this will do both variable selection, and it'll also shrink your parameter estimates. So we won't have time to go there. Mixed models. If you have JMP Pro, we've added a number of different types of mixed models. So there are a number of different types of repeated structures that are available within JMP Pro. If you're dealing with just JMP, most academic licenses have JMP Pro, but you can fit nested designs if you only have JMP. If you're dealing with repeated measures types of designs and the data are in separate columns, MANOVA. And then for survival and reliability, we've got two different platforms here. So let's just start with standard least squares. And I want to build a model. Now down in the bottom is where we put our model effects. So these are the terms in our model. So I'll select pH and polymer. And notice that polymer, if we look back at our data, polymer is a 3-level categorical variable. And we don't have to dummy code this variable. JMP will handle the parameterization for us. One thing to keep in mind is that JMP uses a -1 +1 effect coding scheme rather than the typical 0-1 coding scheme. So if you want to be able to see the parameter coding instead of the effect coding, there's an option under the red triangle on the platform, and I'll show you this once we get there. To add an interaction, I simply select both of the terms and then click cross. And by the way, as we get into design experiments, we'll analyze design experiments from this very same platform. So let me go ahead and click Run. Since pH is a covariate, we get this nice little regression plot. And we've entered an interaction term, so notice that it's giving us the slopes for A and B and C as pH increases. And these lines are not necessarily parallel. So that's a test for parallelism that we see in our interaction. So as we look down through the other statistical output, we see a plot called the actual by predicted plot, and this gives us an indication of the overall significance of our model. What we're actually looking at is what we observed for a response versus what our model predicted we would get. And the less unexplained variation there is, the tighter these points are to the band, and this blue line represents the mean. Again, we see a summary of fit table, analysis of variance, we see the coefficients in our linear model, and then here's our effects test. So we can see that that two-way interaction is highly significant. We see a residual plot by default, and one of the things I've turned on under the red triangle, and there are a lot of options here, is indicator function parameterization. And this will give us our parameter estimates using the 0-1 coding, if that's your preference. Other options that are available, if you'd like to see the prediction expression written out as a formula, this option show prediction expression. So we see the intercept and the slope for pH, or the coefficient. For polymer, which is categorical, we see a match statement, so we see it here, and we also see it in the interaction. One of the most powerful tools here is called the profiler. So there are a lot of graphical tools for exploring a model, and the profiler allows us to interact with this model that we've just built. What the profiler does is it takes our model and allows us to visualize what happens to the response, and the response is here in red on the side, as we change the value of a particular x. It also allows us to visualize interactions. So if I change from polymer A to polymer B to polymer C, notice that we're observing a change in coal particles, and this is the predicted average and the confidence interval, but I'm also seeing a change in the slope for pH. This is a really nice way of visualizing an interaction. A couple of other features that I'll highlight here, if you click on the red triangle and scroll down, there's a built-in Monte Carlo simulation. So the Monte Carlo simulation will take the model that we fit and the levels that we've selected within this model and allow us to add in random noise to the x's and to the response, and then simulate observations. So this is least squares regression. And let me go back to just for a moment to this platform. If I had selected, for example, a categorical response, this same platform would do nominal logistic regression, and the output that we observe would be analogous to what we've just seen. So very, very powerful and rich platform. But let's talk now about nonlinear modeling. And JMP also has a very rich nonlinear platform. So I'll open a different data set. This one is called US population. And again, this is all data that's in the sample data directory. So here what we're interested in exploring is changes in the US population over time. In this case, we have a stored formula, but let's say we don't understand the nature of the relationship between population and year, but we know it's nonlinear. Under Analyze, Modeling, we select Nonlinear to launch the nonlinear platform. Now from here, if we want to be able to use that formula, we can specify it here. Or if we have some other formula in mind that we know represents the nature of the relationship, then we can select a formula, and then we can also show a graph to be able to explore the parameters for that particular formula. And in this case, we'll start simple, and we'll let JMP do the work for us. My response is population, and I'll enter year as my x. And since year is the x, then it's going to ask JMP to help us pick the formula that makes sense, or pick the model that makes sense. So by default, we get a nice little curve. And then under fit curve, we see a lot of different possible models that we can fit to this data. And I'll start simple and select a quadratic. For any model that we fit, we see a summary at the top. So AIC is Ikeki information criterion. BIC is the Bayesian version of that. And then we see at the bottom for this fitted model, we see the parameter estimates, we see the functional form of the model, and then there are additional options that are available. If we decide that we'd like to save this formula, then we can profile this formula visually, and this uses a similar tool as what we've seen before with the prediction profile, or we can save this formula out to the data table. Well, let's say that we think that there might be a different formula that would make more sense. So for example, we see here in the tail end that it's actually curving up. This probably doesn't make sense. So I'll again go to the red triangle and I'll select a different curve. Okay, so here I've selected the logistic for P, and JMP is comparing these two versus one another. Under AIC weight, JMP is asking, assuming that I've found the right model here between one of these two, what's the probability that the quadratic is actually the right model? Okay. And for any number of models that I fit, we'll see a summary, and then the corresponding statistics for that model will display down below. Once I decide to save a formula, in fact, I'll go ahead and save this guy. Any formula that you save will actually create a new column out in the data table with that stored formula. And you can do this for any model from any platform that you fit. So that's a sneak peek at the nonlinear platform. Let's talk now, and I'll close this, let's talk now about survival and reliability. Let me go ahead and open up a data set and we'll walk through a couple of these. And this is some data on the time for a computer system to execute a program. And we've got the number of users within the system, and we've got the load on the system. Let's start by looking at execute time. I'll use Analyze, Reliability and Survival, and then Life Distribution. This platform can handle censoring. It can also handle competing causes and summarize data. If we select a censor variable, it'll ask us what code within that variable defines censoring. In this case, we'll simply select execute time and then OK. We get the Kaplan-Meier non-parametric curve by default, and this gives us the ability to compare different potential distributions. The scale allows us to produce a probability plot for the given distribution. So here, as I scroll through, the distribution that fits the best is the distribution that will straighten the data out the best. So in this case, notice that for Shays, our points are nearly in a straight line when we apply the scaling for this distribution. Here's normal. Okay. And as I go through these, it gives me an indication of which of these distributions might be the most appropriate. If I select a particular distribution, so simply by clicking this checkbox, then it fits that distribution with confidence bands. And then off to the side, we see a profiler. Again, it looks a lot like the prediction profiler. And what this allows me to do is ask the question, what happens to the probability that the job will have completed at a given point in time? So at 635, the probability that the job is completed is 0.98. At 200, and this may be 200 minutes, it's only 0.76. And there are additional results down below, a hazard profiler, quantile profiler, and more. If we'd like to simultaneously compare different potential distributions, under the red triangle we've got the option to fit all distributions or fit all non-negative. And I'll fit all non-negative here. And as we saw with the nonlinear platform, JMP will allow us to simultaneously compare all of these distributions. In this case, it says that the Shays is indeed the best, but running a close second is the generalized gamma. So this is life distribution. But what if we want to build a model? There are a lot of, again, different options within reliability and survival. Let's focus on the last two. What if I'd like to build a model of execute time based on users and load on the system? There are two different types of models that I can build here, parametric survival and proportional hazard. And the proportional hazard is using the Cox method. This is the non-parametric approach. So I'll use reliability and survival, and then parametric survival. Time to event is time to execute. And I'll fit a full model here with users, load, and their interaction. And to do this, a shortcut is to select the two variables. And if I select macros full factorial, and we'll see this again when we're dealing with DOE data, this will include all main effects and all possible interactions. And again, I'll click Run, and JMP fits the parameter estimates and also produces tests for each of the terms in the model. And as always, there are additional options under the red triangle. So that's a sneak peek at reliability and survival. Again, it's a very rich platform with a variety of different uses. And let's change directions now and talk about DOE. DOE is actually how I first started using JMP probably 20 years ago. To design an experiment, DOE has its own menu. JMP will design all of the classical textbook designs, but we've also added designs for market research, computer simulation experiments, accelerated life testing. There's also a very nice nonlinear design platform. By the way, if you're looking for sample size and power calculations, you'll see them at the bottom of this list. One of the most rich and flexible tools for designing experiments is the custom design platform. And this has become one of my favorite platforms in JMP. What this allows you to do is design an experiment to meet your needs where you've got a lot of flexibility. It allows you to respect the linear constraints that you might have and also the limitations in terms of the possible number of runs that are available. So you can simply add a different type of factor, or however many factors are required. I'll add a continuous and a continuous and maybe a discrete numeric 4 level. If I'm interested in running a split plot type of design where it says easy to change, if I right click here and change this to hard, this indicates that this is going to be a split plot design. And you can use this to design split plot, split plot. I'll go ahead and click continue here. And by default, we see that we've got an intercept, we've got 3 main effects, we've got a quadratic for x3 and a cubic for x3. And notice the estimability is saying estimate these if possible. The minimum number of runs required are 6, and the default is 10. If I add additional terms to this model, so let's say I'd like all possible interactions, I'll select the terms, specify interactions. In this case, I'll simply select second order. And it adds these additional terms to the model, and it updates the number of potential runs. If I go with the default and hit Make Design, we see the design that's been generated. And since I had a hard to change factor, this is a split plot type of design. And it's giving us the ability to look at things like power by giving us an anticipated response. So as I look down below, there are a lot of tools built in here to allow us to evaluate this design. So we've got a power analysis. We've got prediction variance profile, so we can see how the variance changes as we change through the design space. Color map on correlations, and other diagnostic tools for evaluating this model. If I click Make Design, JMP will give us a design table with an indication of the type of design, and this is going to be in random order within the whole plots. And the Y column is where we would enter our responses after we've conducted the trials. On the far side, JMP gives us the type of design we've generated, and the custom designer will generate optimal designs. And it's also giving us the largest model we can fit. So this is the model that we specified when we built the design. And since we've got a whole plot experiment, or a split plot type of design, the default method is REML. So this will allow us to address variance components, or estimate the variance components. If we need to return to the design window that we used to generate this, there's a red triangle next to DOE dialog, and this will allow us to go back and make additional changes. So let's take a look at a design that's already been run. In fact, I'll use a 20-run custom design with 5 factors. So here we've got 5 factors, feed rate through concentration, and we're interested in understanding the percent reacted, and we're actually interested in optimizing this value here. To analyze this, since we designed it in JMP, I can simply run the model, or I can go to Analyze, Fit Model. And again, since I designed this in JMP, the largest possible model that I've specified is automatically fit. And if I hit Run, we see a similar output to what we saw before, the actual by predicted plot, a summary of fit, the analysis of variance, the parameter estimates, And by default, we see the prediction profiler. And again, this can be used for optimization. Let's pretend that I've reduced this model and have reduced it to only terms that are significant. If I'd like to be able to find settings of these factors that will optimize my response, if I click on the red triangle and select Maximize Desirability, JMP will search for the settings that satisfy whatever conditions I've specified, and it'll give me the settings to use to allow me to reach my target. So JMP is telling us if we use a feed rate of 10, 2 for catalyst, 120, 180, and 3, then we'll achieve a percent reacted of 96.6, and here's a confidence interval. And then again, if I'd like to do a simulation based on this, I can launch the Monte Carlo simulator. Okay. So that's a sneak peek of DOE within JMP, and very quickly an overview of our quality tools. All of our quality tools in JMP are under Analyze, Quality, and Process. So we include control charts, measurement system studies for continuous responses or attribute studies, capability studies, and Pareto plot and diagrams. And those are cause and effect diagrams. So a very quick sneak peek at SPC in JMP. If you're not familiar with SPC, this is what we'd like to plot data over time to understand the stability of our process and understand the sources of variation within the process. I'll use Quality and Process Control Chart Builder. And this is a relatively new platform in JMP that's built off of the backbone of the Graph Builder. And this allows us to dynamically create control charts. I'll click and drag diameter. This is my response that I'm interested in. And automatically JMP produces an IR chart. And we see the limits off to the side. And this is data that was subgrouped by day. So I'll click and drag day, and I'll simply drop this onto the graph. And automatically the control limits update, and we see that we've got an X bar in our chart, and the limits are off to the side. If we'd like to change the limits from range to something else, notice that we can either select the options on the side, or simply right-click in the middle of the graph, and then change the limits. So I'll do this as an X bar S chart instead. Okay. In fact, I just changed it on the top, and I can change it on the bottom as well. There we go. If I'd like to be able to stratify this by some other variable, I'll select phase, and I can drag phase or any other variable either to the top or to the bottom, and this will produce separate control limits for each of the levels. So a nice dynamic platform that produces attribute charts and also variables charts and rare events charts. So we're just about out of time. To summarize what we've talked about, tools for summarizing and graphing data, the highlights there were columns viewer for summarizing many variables at a time, distribution for producing numeric summaries, tabulate for producing pivot tables or dynamic summaries of data for a number of different variables, and we saw graph builder for producing dynamic graphics. For statistical intervals and hypothesis tests, we saw that we can use distribution and fit y by x for these. For building models, we took a sneak peek at fit model under the Analyze platform, nonlinear for building nonlinear models, and reliability and survival for dealing with time to event data. For designing experiments, all experimental design is done from the DOE platform, but results are analyzed from fit model. And all of the quality and process tools are grouped together under this option, quality and process.